Hi guys, thank you so much for staying to the end of the session for my talk. I'm going to get through this as quick as we can so we can all go out and get something to eat soon. I'm Stevie, Chancellor. I'm at Georgia Tech. And on behalf of my co-authors, Yannis, Jessica, Munmun, and Ayman, I'm going to talk to you about a deep learning approach on how to classify moderated online pro-eating disorder content on Tumblr. So there's a lot of buzzwords in there, so let's get into it so we can unpack this. So social media obviously plays a huge role in our lives, and the kinds of content posted to places like Tumblr can capture our thoughts, emotions, and feelings, and sometimes make us laugh. These are a few posts I pulled from Tumblr's trending topics yesterday, and I think these content show that sharing content is not only enjoyable for us to consume, we like to have a laugh, but also in many cases connects us to others. However, not all content is so positive on social networks, and some is actively malicious or harmful. And these kinds of deviant behaviors like spamming or trolling or posting more obscene content as mentioned in these news articles have challenged online communities since their inception. And what kinds of content sites consider deviant is based on the norms of the community and is oftentimes captured in their terms of service, community guidelines, Reddit, and in other places. To deal with deviant content, platforms incorporate some kinds of moderation to catch this kind of behavior. And most approaches today, even if they do have some automated backends, use human moderators to capture a variety of kinds of content. And this is common across all social networks, not just Tumblr specifically. And this problem is exacerbated as platforms are getting larger and larger and people are posting more content. On Tumblr, 32 million posts are put up onto the site a day. On Instagram, 90+ million photos are uploaded by users every single day. And so the moderation strategies that these platforms adopt become more challenging, especially with content that must be moderated by humans. So one kind of content that challenges social networks is deviant health content. And the one that we use in our study is the pro-eating disorder community, because it's widely banned across many different sites. The pro-eating disorder community glorifies eating disorders as a lifestyle choice, and members of these communities post motivational photos like the ones you see over here, strict diet advice, and encouragement to keep losing weight. And these content, like I mentioned before, are banned by Tumblr's community guidelines because it promotes self-harm and self-injury. And this is just one sample of the deviant health behaviors you might see on sites that might also encourage other people to self-harm. But we like this study in particular because of two reasons. The first is that the eating disorder community is highly visual, and almost all of their content comes with images. And this is backed up by the psychological research that shows that people who suffer from eating disorders are incredibly receptive to the images that they see, and it modifies their self-image and body positivity in very negative ways. So in particular, though, you might ask, well, why are you looking at deviant health behavior content? There's lots of other things that you could take and understand. And we think that there's three really unique reasons why this kind of content is challenging for social networks. The first is it's just not reported. If you're seeking out pro-eating disorder content to maintain these kinds of lifestyles, you're not going to report it because it's what you want to see. More importantly, you and I don't see this content across our feeds because users in these communities use obscure words and tags to hide from other people like their friends and families when they use to post on these websites. But more importantly, we think that this is really complex content. Both it's represented in visual nature as those, but also in those complicated texts. As I mentioned earlier, the tags are kind of obscure. But also the content is deeply subtle. These are two images that I've taken from the data set that are still available. And without knowing the tags, you might not know how these posts are being used to motivate disordered eating behaviors. Finally, though, the content is emotionally sensitive. The photos I show you here and on the last slide only scratch the surface of how graphic this kind of content can get. And analyzing this content is an emotionally draining and exhausting process. And we think that maybe there are automated approaches that might be able to alleviate how emotional and how draining this task is. So our contribution with this paper is that we use deep learning, computer vision, and human sensitivity to develop a method that identifies multimodal removed content on Tumblr. So let's unpack some of the words that are on this slide. Deep learning leverages neural networks, and recent advancements in this field have allowed scientists to be able to explore latent relationships in text and images. Related to the advances in deep learning, computer vision has sort of leveraged these neural networks to explore and understand images. And in the last few years, since about 2011, 2012, it's seen a revolution because it's been able to use these neural networks to improve their accuracies and go through millions of photos. Finally, we use human sensitivity. Because of the complexity of this content and its sensitivity, we think that by bringing humans into the loop to facilitate and understand these algorithmic approaches, that our algorithmic strategy that we adopt is going to be bolstered by these human sensitivities and judgments in what can be a very complex content area. So today I'm going to walk you through the methodology that we adopted that pulls in humans in the loop to understand what kind of content might be removed from Tumblr for violating its community guidelines. The first step is gathering data from Tumblr and identifying removed content. The second step is to bootstrap more examples, and to resolve the complexities I mentioned before, we adopt a process of human annotation of 6,000 posts in this data set. The third is we generate our features using a multimodal approach. We gather visual signals from the images with a convolutional neural network. And from the tags, we find the word embeddings that show the latent relationships and the contextual links within the tags that are used on these posts. Finally, we take all of these features and roll them into our own from-scratch trained deep neural network to identify posts that we believe should be removed off the platform. So to start, we got to go get some data. We gather 877,000 public Tumblr posts that are public photo Tumblr posts that have a pro-eating disorder hashtag. We also grab a control data set of about 10,000 public posts similar to, but topically unrelated to eating disorders. We gather this data in June of 2016, and we wait 4 months to see what the Tumblr moderators take down. In September of 2016, we regather this 877,000 post data set, and we find that only 569 posts have been removed from the platform between June and September. Now you might be thinking, Stevie, is that a lot? Is that not many? Let's talk about why we think this number is what it is. And to be honest, we weren't totally surprised. As I mentioned earlier, this content isn't reported to moderators. And so if the moderators themselves aren't actively going out and seeking it, it's unlikely that this kind of content would come across their desks in the first place. But we also think that this number is artificially small because we can't see the stuff that Tumblr moderated as okay. This only reflects the kind of stuff that Tumblr actively took down off of the platform. So to resolve these complexities, as well as to bootstrap more examples, we adopt a human rating task using 3 experts in social computing and pro-eating disorder research. And the goal of this is to boost the size of our data set and to begin to resolve these complexities, like I mentioned, of posts that were allowed to stay up on Tumblr but were reported anyways. So let's walk through a quick example of the rating task to show you how important the images and the text are together. You can see 3 images here from our data set and the accompanying a sample of the accompanying tags that came with them. Most of them use tags such as thinspo, ana, and anorexia, which are kind of overarching tags that are used on the pro-eating disorder community in Tumblr. But if you start to unpack the tags, as well as the visual signals that go along with them, some of these images signal more dangerous behaviors and encouragement of disordered eating habits that indicates that they should be taken down. And this is where we get our ratings of 1, 2, and 3. 1 is the post that we believe should be allowed to stay up on Tumblr's platform. 3 is something that we judge to violate Tumblr's community guidelines for self-harm. And we captured the 2s, which were we think that these are concerning, but they should be allowed to stay up, to capture that gray area that I mentioned earlier. So using all of this data that we've labeled, we then generate our multimodal features. So for our visual signals, we use AlexNet to generate our visual features. There's many implementations in computer vision of architectures that you can use to identify signatures and images, but we pick AlexNet because of its long history of working well across many data sets. It's been in adoption in the CV community since about 2012. And after principal component analysis, to reduce the number of features so we don't overfit to our model, we end up with 128 dimensions that we pass to our neural network. To unpack the contextual information from tags, we adopt a word-to-vec embedding system. Word-to-vec transforms words and its latent relationships to other words in a sentence into vector space. And you can do math and compare the similarity scores of words within a sentence without having to rely on things like n-grams or TF-IDF. It brings this contextual information to light very quickly. And to show this, one of the word embedding outputs was for anorexia, we got word embeddings like starvation and calorie restriction, compared to something like bulimia, which related closely to purging and restricting, which is what you would expect based on these disorders as something that people would connect to semantically. Given that we have so many data sets, we should definitely walk through how we break up our data so we can train our algorithm. Our positive class is posts that we believe should be taken down from Tumblr. For our training and validation stage, we use posts rated as 3. This is to preserve the gold standard labels that we have from those 569 posts that we know for testing. And we want to test on this because we know that this is content actively taken down from Tumblr's platforms. Posts that were in the negative class, or posts that should not be taken down, are a combination of posts rated 1 and 2. Again, we bring the 2s in to increase the complexity and the challengingness of our algorithmic approach, as well as the posts related to the eating disorder set. So I'm going to show you the results from 4 algorithms we trained. We're going to compare first the text-only and image-only SVMs to a multimodal SVM, since that's currently state-of-the-art in supervised learning. You can see that the text-only and image-only SVM approaches don't actually perform that well, especially in the areas of precision and recall, which means we're going to get a lot of false positives and a lot of false negatives in these data sets. But when we move to the multimodal approach, we notice that accuracy jumps significantly, as well as a boost in precision and recall, showing that taking a multimodal approach improves over text-only or image-only approaches by themselves. Now we show you also the accuracy and metrics from our multimodal deep neural network. And you can see that there's a substantial gain in accuracy, but we also see a nice jump in precision as well, which shows that our system is able to better identify or not identify as many false positives, which can matter a lot in the implementations of such systems. So overall, we've adopted this system that uses human inferences and understanding of a sensitive content area. And in each step, we use these human judgments and understanding to develop a semi-automated approach to identifying content that's been taken off of Tumblr for violating community guidelines. And so you might be thinking, okay, now we've got this awesome algorithm. How could this method help moderators who are overstrained and overworked because of the volume and the sensitivity of this kind of content? And the first approach that we think that you could use this algorithm in is a first-pass system to help moderators quickly identify candidates for removal. As you mentioned earlier, this content is challenging, and that all of these posts might not necessarily be candidates for being taken down. And we still want moderators to give their judgments because of their ability to see these complexities and these subtleties. And so we imagine this system being adopted as a first pass to help moderators narrow the space of content that might be taken down that might not be getting reported to them. The second approach that we think that would be useful for moderators is an online learning approach that over time uses the results of moderation, both the actually should be taken down and the choices that moderators make to allow things to stay up to boost the accuracy of the model. And this would need to be trained over time and could be trained for specific instances catering to specific platforms. Finally, we think that you could use this algorithm too to develop moderator training tools. When there's a lot of challenging content that might not necessarily be clear about how to moderate it, new moderators might not know what to do when they begin. And so we think that you could use this kind of approach to teach new moderators how to handle sensitive content. You know, what are the 1s and the 2s? What's the difference between a 2 and a 3? Here are some challenging examples that the algorithms missed before that you need to look out for during your training. So with that, I invite you to ask me questions. I want to quickly thank Yahoo Research, both for hosting me last summer, where I did the bulk of this work, as well as for providing Munmun a faculty engagement award. Thank you.
Hey, Ani from Amazon again. Could you go back to your results page?
Which slide?
The results slide where you have the numbers?
Yeah.
Right. So yeah, this shows that the neural network gives improvement over the multimodal SVM. But so there is a huge trade-off here in that if you actually deploy this and in scale with larger data, the amount of resources, both in time and computing, would be much higher for a neural network system versus the SVM. Do you think the trade-off is worth it, where the results, I mean, so it does perform better than the multimodal SVM in almost every aspect, but only so much so? Do you think it's worth it, the trade-off?
So I think this is a proof of concept of a deep learning approach to being able to solve complex moderation strategies.
Right.
And one of the limitations that we have in the studies, we only have 570 ground truth examples. What I think could happen is if this was deployed into an actual system, you could have larger sets of data. And I think that, to your point about whether or not this trade-off is worth it, I think that the trade-off specifically in precision matters a lot, because you don't want to remove posts off of a platform that might be totally in conformance for guidelines, because that's going to have negative impacts on user retention and community, the community on the platform. And so, yeah, I think that with a more technical approach that I did not show here, you could definitely get this to work, and it would be worth it.
Great work, thank you.
Thanks.
Hello, this is very nice work. So this is Dee from Carnegie Mellon. I have a question regarding the text-only version models. So you said you use the word to vector, like which corpus you used to train this? Because in those social settings, people use a lot of out of vocabulary words. So when you say happy, you add a lot of P into the word. So this word might not have corresponding embeddings in the word to vector. How did you deal with this?
Can you repeat your question again?
For your word to vector, right?
Mm-hmm.
Which corpus you used to train it?
Do you mean which algorithm versus bag of words or skip ground?
No. You need to train your word to vector based on a corpus, right?
Based on, the corpus is the tags.
It's specific for this context, or it's on news or other?
Oh, no, it's specifically on these words.
Okay.
So it's on that whole data set of the posts that we rated, the moderator removals, and the posts that are related to it.
Okay. Do you remember how large is that?
I think that there's a lot of posts, a lot of tags per post. Normally they have 4 tags, but in the eating disorder community, they use tags very aggressively, 10 to 15 tags. And we saw some posts that had up to 30. So I think it's actually a pretty decent representation because of the aggressive tag use by these communities.
Okay, thank you.
Mm-hmm.
Nice work. Zubair Shafiq, University of Iowa. So your approach seems to be fairly generic, and I'm starting to think if this can be, in a straightforward way, generalized to other challenging problems like detecting violence, related content, or things like, for example, nudity, which is posted in online communities.
Yeah, I think that there are a lot of ways that this approach could be adopted, both when you use experts who are knowledgeable in a specific content domain, like nudity or other kinds of obscene or harassing content, but also I think that the approach sort of broadly can be applied to other content domains. And I think one great future work is seeing if this kind of work will work across multiple domains as well. But yeah, I totally agree with you.